Okay, so for section 1.4, we're talking about quadratic equations. Quadratic equation is one of the form ax squared plus bx plus c equals 0. Like I said a moment ago, bx plus c was just our linear, but when we add this extra term and now go with a power of 2, we have what's called a quadratic equation. Now, doesn't make any sense to me because when I see the word quad, what do I think of? What number do you think of when you see quad? 4? Yeah. So I don't know why it's called a quadratic equation. I know a lot of stuff and make up a lot of stuff, but I don't know that answer. All right, some of the lingo that goes along with this. The leading coefficient is that A part, the number out front. Normally, we see that being just a 1. Coming out of a previous math course, most of the work was done with that leading coefficient of 1, but in reality, it's going to be something different than 1 sometime. Constant term, that's this puppy right here. That term doesn't change no matter what. So keeping up with some of the lingo, I have the leading coefficient, I have the constant term, I have working with quadratic equations. Now, just like we did with linears, I want to be able to solve these because I have an equation, that's the equals, and this guy equals 0. That's a big key. Most of the time in order to work with these problems, and you already know this, you have to set it equal to 0. All right, so let's see, let's solve them. Well, the first one, I'm looking at the directions. I didn't just start doing problems. And I see that the 0 product property. That means I have a product and it equals 0. M times n equals 0, then m equals 0 or n equals 0. 0 product m times n. So if I can rewrite my quadratic equation like that, woohoo. Now you were just in groups and hopefully you said, okay, I want to make it look like, right there it is, a quadratic equation. So the first thing I have to do is get it in a quadratic equation form. Distribute the x, bring the 15 over, and now I factor. This had to be 2x, that had to be x. I had to find the right combination of outer and inner. 6x and negative 5x gives me just that x. I'm kind of happy with that because once I factor, I now have m times n equals 0. M equals 0, n equals 0. Did any of the groups get the first one? X equals 5 halves and x equals negative 3.
I got negative 5/2 and positive 3.
Then maybe I messed up. If I come back up, I need a positive x here. So 2x minus 5x plus 3. 6x is my outer minus 5x. So that has to be x. So x is, I think I'm right here with x is negative 3. X is positive 5 halves. And of course, heaven forbid, what if I wanted to check it? Well, that's extra work, but I could put the negative 3 in up here and a negative 3 here, and I end up with negative 3 times negative 5 is 15. So I think that's right. Number 2, I'm going to get it equal to 0. Cool. I don't have a 0 product yet, but I have 0. So I need to rewrite this as a product. When I have only 2 terms, I factor. I pulled out the 8x. Now I have 8x times 3x minus 1. I get 0 and 1/3. I'm willing to bet when you all went into groups, you just sat there and worked on your own. Does that sound about right so far? Kind of, yeah. We're going to work on how we can improve group work. Because I don't like to do all the talking. I like you folks to do talking. Okay, so sometimes I will get an equation and it's good. Oh, solve quadratic equations. Boy, that's boring as heck. Why don't they call this quadratics? Missing the linear term, the x to the first term, that middle term, right? The one that's in the middle. You notice we have the x squared term for each of these. And we have the constant term, but we don't have an x term. And when I do that, I can use this thing called the square root property. Yeah, divide by 3. So now I have x squared equals number, woohoo, x equals plus or minus 2. Oh, there's that. Working with imaginary numbers again. X equals plus or minus. But you notice there's 2 solutions to this. Square root. I send the 7 over and it's a negative. Plus or minus square root of 8. Negative 7 plus or minus 2 square root of 2. What you think about that? All right, so these were some of the easier ones. You know, I threw these 5 at you, and these were in fact some of the easier ones up to this point. Now I'm going to get more quadratic equations, and I need to learn some different ways to solve it. And down here at the bottom of the page, you see something called completing the square. In our math world, most students like to avoid this method, but it's one that's going to be a building block for something down the road. So it's good to learn about completing the square. And again, I'm going to take a quadratic, and I can take all quadratics and solve them this way. This is one of those blanket ways to do it that nobody does it, because you find simpler ways. But let's see, what do I have here? Oh boy, step 1, divide by both sides by a. To make the leading coefficient 1, I'd have to divide everything by a. Isolate the variable term on one side. Okay, that would be the variables. They're the ones with the x's in. Complete the square, and I need to add the square of 1/2 the linear term coefficient both sides of the factors, and you're scratching your head going, I don't know what the heck that means. And apply the square root. Oh boy, looks easy, right? No. Let's see what we have. When I complete the square, I'm going to get to something that looks like this. Okay, I'm going to get to something that looks like that. And if I can take a quadratic and get it to this, I can solve it just like I did with number 5. So that's going to be how we're going to make it look. We're just not there yet. First things first, it said, divide everything by a. Right now, what is my a? A
1.
equals 1. Yeah. So if I divide everything by 1, it doesn't change my question. It leaves it as x squared minus 18x plus 5 equals 0. Down here, I'm going to have to divide everything by, it looks like 2. Yeah. Okay. I'm going to come back up here. I'm going to go read step 2. Step 2 said isolate the variable. Oh boy. Step 2 says, let's get the variables alone, which means I'm going to subtract 5 from both sides. So why didn't they say, send the constant term to the other side? I don't know why, but they didn't. Now I need to pick a number that's going to make this side a perfect square. And what do I mean by that? Well, let's take a look at some examples over here. If I said x squared minus 4x plus 4, what does that factor into? Let's change that. Let's make it x squared plus 4x plus 4. Keep it easy right now. What does that factor into? X plus 2, x plus 2. And guess what? That is what's meant by a perfect square. Okay? Because it factors into something times itself. X squared minus 6x plus 9. I like that. That's x minus 3 times x minus 3. That is a perfect square. X squared minus 18x. I don't know this off the top of my head, but here's how we're going to figure out what that number needs to be. Because over here, I need to know what that number is going to be. So let's see, when this was 4x, I needed 2 and 2 to get to 4, right? Here's negative 6. I needed to get to negative 3. Here's negative 18. Let's see, is there a pattern? Plus 4 became plus 2, plus 2. Minus 6 became minus 3, minus 3. How did I get those numbers? I took the 4, I took the negative 6, and I cut it in 4-letter word. Starts with H.
Half.
Half, right? I cut it in half. So for this guy, I'm going to cut it in half because I want it to be x minus 9, x minus 9. So woohoo, I halved it. Halved it. Now, what is negative 9 times negative 9? Because once I know what this number is, I can go, woohoo, I have a perfect square. What's negative 9 times negative 9?
Is it positive 81?
Excellent, positive 81. So that means I'm going to come back up to my equation. I'm going to do what I call half it, square it. I'm going to take the negative 18, I'm going to cut it in half, which is negative 9. I'm going to square, I'm going to add 81 to this side, and I'm going to add 81 to that side. So now my step 3, when I factor this, I'm going to get that perfect square. X minus 9, x minus 9. Over on the right side, 76 trombones will lead the parade. Step 4, x minus 9 equals plus or minus the square root of 76. X equals 9 plus or minus the square root of 76. Oh, 76 divided by 2 is 2 and 38, and that's 2 and 19. So x equals 9 plus or minus the square root of 4 times 19, which means I'm going to be able to pull that 2 out, and that's all I'm going to say about that. I solved for x. I solved for x because this is one that I couldn't factor. Couldn't do it easily by hand. So now I had to up the price of poker. I had to step up my game a little bit. I sent the constant term over. Well, actually, I divided by the leading coefficient, which I didn't have to do much work there. I sent the constant term over. I halved it and squared it, added that both 81s to both sides, made this a perfect square. This is back to that problem on the previous page. So you know how we broke these up, and so you can start to see where little things we've learned before, we're building upon them. Pick a number, 7 or 8. We're only going to do one of these. 7, please pick 7. 7, thank you, Nina. I'm going to pause the recording. I'm going to give you about 3 minutes on your own to see how far you can get. Recording is now being paused. Recording resumed. All right, let's see how far you got. First thing I need to do is make this a 1 out front. So I'm going to divide everything on both sides by 2, the leading coefficient. X squared minus 2x minus 3/2 equals 0. Next thing I'm going to do is get rid of the constant term. X squared minus 2x equals 3/2. I added 3/2 to both sides. Now I need to complete the square. I'm going to take half of this, which is -1, and square it. I'm going to add 1 and add 1. And here we go. Remember when I halved it? It was -1, and there it is. 3/2 plus 1, 5/2. Now I'm back to that first page. Hey, these aren't so bad, right? Get rid of the leading coefficient by dividing everything by it to make that x squared. Send that constant term over, half it and square it. Now go from here. X minus 1 equals plus or minus the square root of 5/2. I add 1 plus or minus the square root of 5/2. We're going to let it just like that. Questions? Over here, it wasn't a quadratic equation yet. So I had to bring the -2x over. Very first thing I do is divide by 3 and then follow all the steps as we did before. All right, completing the square. Love it. Love it. Okay, the next thing, what do we have here? Solve the equation by the quadratic formula. Whoop, there it is. And if you take a look at this, this actually looks like what we were doing a moment ago, where I ended up with, yeah, if I took ax squared plus bx plus c, and instead of using numbers, let them as a, b, and c, and I did the completing the square, where I divide everything by a and send the constant term over and did all that generic work, this is what I would end up with. And this is what a lot of you know, the quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Compared to completing the square, what do I have to do first? What do I have to do first here with the quadratic equation? Tell me something good.
Distribute.
Distribute? Yep. I need to make it a quadratic equation first. There's nothing I'm going to do with this bad boy. So I distribute to 2x. I'm now going to, do I need to bring the 7 over, or can I just leave it over there for right now? Well, I can bring it over and go, okay, check. It is a quadratic. I'm happy and I'm ready to go. Now, at this point, I can either use the quadratic formula, which we're going to do, or I could have used the completing the square method, which we're not going to do. X equals the opposite of b, 6, plus or minus the square root of b squared. -6 squared is 36 minus 4 times a, 4 times a times c. What is 4 times a times c?
What is it?
56 over, all. Some people only put the second part over. It's all over 2 times a, 4. Now I'm back to some of those simple things I did before, cleaning up. 6 plus or minus the square root of -20 over 4. That's going to give me 6 over 4 plus or minus, square root of -20. square root of negative 20. That's the square root of negative 1 times 4 times 5 is going to give me 2i square root of 5 all over 4. 3 halves as I reduce I square root of 5 over 2. Yay! If I did a poll real quick, how many of you remember the quadratic formula? A lot of you would say, I knew there was something like that. I didn't remember it existing exactly, and that's fine. So I have a bunch of different ways to solve quadratic equations today. Bunch of different ways. Factoring is a big one. You should have really practiced that in a class before you came here. Now, a quadratic equation, if I was to graph this, y equals ax squared plus bx plus c, okay? If I was to graph a quadratic equation, what shape is it? Do y'all know what shape that is? Do any of you know what shape it is? Any
U.
It is a U, right? It is a U. And when I graph that U, there's going to be 3 possible graphs that come into play. The first graph is going to go something like that. And when I change this Y to a 0, I'm finding what's called an intercept. And we'll go deeper into this later. But when I do this and I factor and I find them, I'm finding 2 roots. Remember, a lot of those problems we found x equals 3 and x equaled 5 halves or something like that. Those guys are the roots. That's where it crossed. So this might be something like, I got it down to x plus 2 and x minus 2. And I crossed at 2 and 2. So there's possibly 2 real roots. All right, that's cool. I could possibly have one that comes down and just touches. That's one, and we would refer to that as one real root. And that might be something where I have an equation of x plus 2, x plus 2. They're the same. They factored into being the same thing. We call that a double root. And then there's finally floaties up here, right? And this is one, there are no real roots. There are what we would call 2 imaginary roots. And that's answers like this guy up here. It didn't come out to be nice numbers when I set my quadratic equal to 0. So I would have 2 imaginary roots. So I have a couple different ways of answers I'm getting. There's 2 imaginaries. Like I said, that means this graph would be a floating U. If I came over here and I looked at this guy, right here, okay, here. This is a real number. So this is going to be some kind of crazy decimal, but this guy is going to cross twice. I have 2 real numbers. All right. Well, we can pick out early on what kind this is going to be. Is it going to have 2 real roots, 1 real root, or 2 imaginary? And the way we do that is we look at what's inside the square root. What's inside the square root? And it's called the discriminant. That's the b squared minus 4ac. So if the discriminant becomes 0, that means this guy right here is going to happen, 1 real root. If the discriminant is positive, then I know I'm going to have 2 real roots. And if it's going to be an imaginary, then I know I have that. So if I start doing some work, blah, 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 and I get 6 plus or minus the square root of 0 over 11, I'm going, uh-oh, I only have 1 root, and that's 6 over 11. 1 root. If I had something like 6 plus or minus 14 over 2. Now I know I'm going to have 2 roots. Because it's going to be 6 plus some number and 6 minus some number. And I would get 2 answers, the 6 plus and the 6 minus. And then, of course, we have the ever popular, dangerous, there's a negative inside of there. And that's going to be my floaty. That's the 2 imaginary roots. So if I started to do this guy right here, this says my discriminant becomes 0. So my b squared minus 4ac. That's what I'm looking at. The b squared minus 4ac. B squared, 100, minus 4 times 1 times 25 is 100. My discriminant is 0. That means this graph, if I went to graph him, I'm only going to have one place where it touches the x-axis. I only have one root. Over here, x squared equals 3. That was one of my methods that I had. I'm missing that middle term. X equals plus or minus 3. I have 2 roots. It's going to cross at 3 and negative 3. Okay, I want to look at the discriminant. B squared, that's going to be 0 minus 4 times A times C is negative 36. Yep, my discriminant is 36. Boom. So I'm looking at the discriminant and it's going to tell me about my roots. If I look at the discriminant, B squared, 36 minus 4 times A times C, which is 8. 36 minus 8 is 28. It's going to be 2 real roots. And we'll talk about the discriminant more. It comes and goes in popularity, but we definitely will come back to that. Negatives, right? This is going to be the 2 imaginary. The discriminant, b squared minus 4ac. 9 minus 4 times 1 times 5 is 20. That discriminant is negative 11. That means in my square root, I'm going to have negative 11, 2 imaginary roots. That is one of the tougher sections that you're going to see for a while. There was a lot of stuff into that. And just like in section 1.1, we're now going to take a look at some problems that are going to give me an equation that's going to be quadratic. Now, some of you just started sweating bullets because you're like, I got all that stuff in 1.4. I don't know how to do word problems. Well, let's do a couple and see if we can get some confidence going here in 1.5. So we can get them set up. Now it's a matter of using 1.4 to solve them. So let's take a look at number 2 to start. Oh boy. All right. 3 sides of a right triangle are represented by 3 consecutive integers. All right. I need to understand what consecutive integers are. All right. What are the integers? The 3 sides of a right triangle are represented by 3 consecutive integers. All right. So if I said 4, what's the next integer?
5.
And the next integer?
6.
Right. You went from 4, you added 1, and then you added another 1. If I said, and I hate X all the time, I'm going to use S for side. If I said S, what would be the next one? If I called this S.
S plus 1.
S plus 1, and what would be the next one?
S plus 2.
Excellent. So they're my 3 sides. And I want to know what they are. Some of you are going, oh my goodness, I don't know. I understood the 3 consecutive integer part. But what I now need to come back to is say, wait a minute, that's a right triangle. And if I got ready and said S plus 1, and s plus 2. What is it I know about a right triangle? What have we learned about a right triangle? We have a formula, right?
Yes.
What's our formula? Starts with a P. He had a society of mathematicians and women weren't allowed in.
Pythagoras?
Pythagoras, right? I'm going to use the Pythagorean theorem. It says s squared plus s plus 1 squared equals s plus 2 squared. Whoop, there it is. You're going to town now. Yeah, I can do that. That's s squared plus, let's see, this becomes s plus 1. Oh, yeah, don't you dare distribute. This is the same as a plus b times a plus b. Now I can do the whole double distribute or FOIL, whatever you want. But this guy should become s squared plus 2s plus 1. Same thing over here. S squared plus 2s and 2s is 4s plus 4. Whoop, whoop. So what I'm doing is I'm looking for an answer. I'm looking to find out what s is. I'm going to take that s. I'm going to add 1 and I'm going to add 2 and I'll get my answers. This becomes 2s squared plus 2s plus 1, s squared plus 4s plus 4. Well, now I know why they don't use s as a variable too often, because s can quickly look like a what? Say 5.
It looks like a 5.
It does. It will end up looking like a 5, but we're no better. I'm going to subtract an s squared from both sides. That's going to give me s squared. I'm going to subtract 4s from both sides. That's going to give me a minus 2s. I'm going to subtract 4 from both sides. That's going to give me a minus 3. And now I have my quadratic equation. Whoop, whoop. I have a whole section worth of ways to solve this quadratic equation. Tell me something good. Well, we're going to have to factor it. So I can use that zero product property. It's going to be s and s.
Would it be s plus 1 and s minus 3?
You are correct. Zero product, s plus 1 equals 0, s minus 3 equals 0. What is s? Is -1 a valid answer? Somebody say no. Because I can't have a side that's length -1. How about 3? Yeah, 3. That means my second side is 4. My third side is 5. There are the 3 sides, 3, 4, 5. And you're going, oh, that's right. That was one of my Pythagorean triples that we talked about the other day. I got one. It was easy when I did it. But oh, hey, we lost 2 people already. People are ducking out early today. Let's try another one. All right, let's do number 3. I hate word problems. I hate math. I hate word problems. I hate 8 o'clock. I hate everything right now. No, it's not so bad. As the minute hand of the face of the clock sweeps around once, it covers an area of 114 square inches. What is the length of the minute hand? Are you kidding me? All right, let's start out with a clock. What shape is the clock? Something went crazy there.